Okay, welcome back. In this video we're going to look at polynomials, specifically a more introductory approach to polynomials. So first of all, polynomials are expressions that are made up of both numbers and letters. Okay, now remember, letters we call variables. That's the fancy term, but basically it boils down to letters. Now we have some different types. First of all, we have to know what a monomial is. So a monomial is an expression that involves only one. Now you can have multiplication or division. You can have a combination of a number and a variable, but you've only got one single term. Okay? Now, coefficient is the big fancy word for the number in front of the variable. Okay, so the partner. Whenever you see a letter and it has a number attached, that number is a coefficient. A constant is if you just have a number totally by itself. So in terms of a coefficient, for example, we may be looking at something like 3x. Okay, or we could be looking at something like 1/2 x to the third. Okay, anything to that effect. The coefficient is the number part, so this part here is called your coefficient, whereas the x here would be called your variable. Okay. Now in terms of a constant, that would be a number only. So for example, we could look at the number 4, okay, or we could look at the number 7/8, etc. Those would be constants. Notice they don't have any variables attached to them at all. Now descending order means largest to smallest. So what that means is that you are going to write your largest term first. When we're talking about largest, we are talking about highest power. When we talk about the smallest, we are talking about the lowest power or a constant. Okay. Now we do have some types. So a monomial has only one term. Binomial would have two terms. So for example, we could see something along the lines of 2x plus 4. Notice this is two terms. Okay? Notice I went from my highest power down to my lowest, or my constant. The constant always makes up the last part of your equation. Okay? A trinomial is a polynomial with three terms. So for example, we may have something like 3x cubed plus 4x squared minus 6. Notice I have 1, 2, 3 terms, and that was it. And then a polynomial is basically any monomial, or essentially any. So we have an unlimited amount of terms. So here we may have 4 or more terms. So we're looking at 4 or more terms here. Okay. So let's see some of these things in action. So we have that we need to identify the expression as a monomial, binomial, trinomial, or not a polynomial, and then we need to determine the degree. So first we need to know what a degree is. Okay, so a degree is the number of the exponent. Now, when we want to know the degree of a polynomial, okay, our degree of a polynomial is the highest exponent, or for better known as power. Okay. So first I have 5y squared minus a 2y plus 1. So the first thing that we need to do is we need to identify it. So in order to identify, we need to know how many terms. Well, I have 3 individual terms. So when we have 3 terms, this means that we have a trinomial, where the word tri means 3 terms. Now we need to determine the degree of each term and then the overall degree of the polynomial. So to find my degree of the terms, I want to look at all of them separately. So I have 5y squared, I have a negative 2y, and I have a 1. So when I'm looking at the degree, I am looking purely at the power. So my first term has a degree of 2. Notice in this term, if you look, my power is not written, which means it's a power of 1. So my second term has a degree of 1. And then obviously this is my constant. And so when we're talking about constants, we're not necessarily talking about degrees. However, if we were to have something here, we would say that this would be a degree of 0. And our reasoning is because this is a constant term, which means there's no variable. Now, if I want to know the degree of the polynomial, what I need is I need the highest power. So for here, in looking at the highest power, the degree of my polynomial is going to come from degree of 2, because 2 is my highest power. So here we have that your degree is 2. Alright, let's look at another one. So in this case, I have 6m cubed plus 5m squared minus m to the negative 3. Now your instincts might tell you that this would be 3 terms. However, we've got a problem term. My problem term is right here. You cannot have a negative power. Therefore, this is not a polynomial. Since it is not a polynomial, there is no degree to look at. Okay? So you got to pay very close attention. So that being said, when we are looking at our polynomials, there's one important thing that you have to pay attention to. So my note here is the following. A polynomial must have all positive powers. Okay, so this here would be your biggest takeaway, is that a polynomial must have positive powers. You cannot have negative powers. Okay. Alright, let's look at another one here. This example says that we want to simplify each polynomial. We want to write them in descending order and then state the degree and type of the simplified polynomial. And then finally state the leading coefficient. So simplified essentially means we have to combine like terms. Okay, that is what simplifying means. So here I have a 4x squared and an x squared, so I'm going to write them together. So 4x squared plus x squared minus x. So I have 4 of them, I'm adding one more. These are going to combine together and give me 5x squared minus x. There's nothing else to combine here because x squared and x are two completely separate terms. So now we can go ahead and take a look at it. Here, in terms of my terms, I have 2 of them. Therefore, this would be called a binomial. Bi meaning 2 terms. Now, the other thing that we have to do is we need to find the degree. So my degree is again my highest power. And so my highest power is going to be this power right here of my first term. And so here my degree is 2. And the reason for that is because this is your highest power. Now a leading coefficient, okay, that's a new term that we have. So leading coefficient. What this means is this is going to be the coefficient attached to the highest power term. So my leading coefficient is my coefficient attached to the highest power term. So my highest power term is going to be this first term, which is why it's called leading coefficient. And I want to know what the coefficient is. So coefficient, again, remember we are talking about the number that is attached to the highest power term. So here my leading coefficient, so my LC or leading coefficient is going to be 5. Okay, so that is how we identify our terms. Alright, let's look at this next example and do the same thing all over again. So here we need to combine my terms. I have a 2x, a negative x, and a negative 2x, so I'm going to write them together. So 2x minus x minus a 2x, and then I have plus 9 and plus 1. So when I look at this first 3 and I combine them, 2x minus 2x goes away, leaves me with a negative x, and then I have 9 plus 1 gives me plus 10. Again, if I look at what I have here, I have a binomial because I've got 2 terms. If I want to know my degree is looking at the power of my largest term. Again, if it's not listed, this means that it is actually a 1. So here my degree is going to be a 1. And then when I'm looking for that leading coefficient, I'm looking at the number attached to the x variable. So specifically I'm looking at this number that falls right here. Since I only have a negative written, remember that's an understated 1. So here my leading coefficient is a negative 1. Alright, let's try another one, slightly bigger. Again, I need to group my terms together. So I have an x to the 4th and a 3x to the 4th. If you look down, there's no others. So when I combine them together, this here is going to give me 4x to the 4th. And then I have my next. So this is going to be my negative 2x and a 5x and an x. So if I group those together, I'm going to end up with negative 2x plus 5x plus x. So this here is going to give me 5 plus 1 is 6 minus 2 gives me a 4x. I then have this x squared, but there's no other x squared terms. So I just have the negative x squared, and then I have this negative 10. So I need to write them in descending order. So I need to go largest down to my smallest and or constant term. So this is talking about powers. So I have power of 4, power of 1, power of 2, power of nothing. My largest power is power of 4, so this becomes 4x to the 4th. I then have to go, so if I go down 4, the next one in the row would be 3. I don't have any. Going down again would be 2, so this becomes minus x squared. I then have 1, so this would be plus 4x, and then my constant, minus 10. So I have stepped my polynomial down, stepping down each power as we go. So now I can start identifying my information. First and foremost, when we're talking about our terms, I have 4 of them. Therefore, we would simply call this a polynomial. Now that being said, I also can look at my degree. So again, your degree is talking about your highest power. And so for this problem, my highest power is right here on my first term. So my highest power would be a 4. And then when we're talking about your leading coefficient, remember we are talking about the number attached to the highest power. So that being said, that means we're talking about this number right out here. And so thus my leading coefficient would be a 4. Okay. So that is, again, being able to identify and break apart the polynomials that you have been given. Now, beyond just identifying the pieces of polynomials, we have to know also how to evaluate them. Evaluating means we are being told what your variable actually is, and so we simply have to do what's called plug and chug and simplify. In other words, I'm giving you the polynomial, so p of x is negative 5x squared minus 8x plus 7. I want to find p of 3. What this actually means is that I want to find my polynomial when x equals negative 3. That's actually what we're saying here. So that says anywhere we have an x, we need to substitute my negative 3. So my p of negative 3 is going to be negative 5 times the negative 3 squared minus 8 times the negative 3 plus 7. The first thing we need to look at is we've got this square, which is going to affect not only the 3, but this negative as well. So here, this is going to be negative 5 times negative and negative is positive. 3 times 3 is 9. Negative and negative is positive, so this becomes plus 8 times 3 is 24, and then plus 7. Negative 5 times 9 is a negative 45, plus my 24 plus 7. And this whole thing is going to give me a negative 14 as a result. So when we're talking about solutions, you would state that p of negative 3 is equal to negative 14. Alright, let's look at another one here. Again, here I have my polynomial stated in proper form, and I want p of negative 2. So as a reminder, again, this is telling you that I want to find my polynomial when x equals negative 2. So anywhere I have an x, I need to plug in negative 2. So p of negative 2 is going to give me negative 2 to the 5th power minus negative 2 cubed plus a negative 2 minus 2. So just like before, we have to look at our power. So here, this is my power of 5. It's going to apply to the 2 and to the negative sign. Remember, negative taken to an odd power leaves a negative behind, so this is negative. And then I have 2 to the 5th, which gives me 32 as a result, so this is negative 32. Again, I have this power of 3, which applies onto the 2 as well as to the negative. So here, remember, negative taken to an odd power is negative. So this is going to be minus, my negative is here to stay, and then 2 cubed is 8. I then have this plus, which gets applied to the inside here. So positive and negative gives me a negative 2, and then minus 2. When we're talking about negative of a negative, remember that changes to become a plus. So here we have negative 32 plus 8 minus 2 minus 2. So here we've got that negative 32 is going to become a negative 28 as a result. So again, if we write our solution, we have that p of negative 2 is going to give us a negative 28. So notice in both of these first two examples, what I was substituting in was a number. Okay? So here, the biggest hint I have is if your substitution value is a number, then your solution should be a number. However, what happens if we are asked to substitute something that is not a number? In other words, given f of x, where I have negative 4x plus 6, I want to find a minus 2. So this essentially again means that I want to find my function where x is equal to a minus 2. So instead of a number, I'm using an expression. So I'm going to have f of a minus 2 is going to give me a negative 4 times a minus 2 plus 6. Now I have to take this negative 4, so this whole negative 4, and I have to distribute it into my parentheses here. So this becomes a negative 4a. Negative and negative is positive. 4 times 2 is 8 plus 6. I need to combine my terms here. So I get negative 4a plus 14. There's nothing else to do, so again here, if we're looking at your solution, we would have that f of a minus 2 is equal to a negative 4a plus 14. So the rule is, if you're supposed to substitute a whole number, then a whole number will be your answer. But if you substitute an expression, then an expression will be your answer. So that's all I have right now for introduction into polynomials. If you have any questions, please let me know. Otherwise, be sure to keep smiling, and I'll see you next time.